In this question from the chapter Similar Triangle, it says through the midpoint M of side CD of a parallelogram ABCD. So what we can do is to first make a parallelogram. Let's say I make a parallelogram and I named it as ABCD. And we are given what? M as the midpoint of side DC. That means DM is equal to CM. Now further it says that we have the line BM, right? BM is drawn intersecting AC at L and AD produced to point E. So let's first join AC. Joining AC first and producing this line BM. So first we'll be joining BM and then producing it. So over till here. Further, it is meeting AD produced. So where is AD? Yeah, AD when produced, let's say if I produce AD, need to be slightly got displaced. Let me adjust it. We can see over here that this is AD, right? This is AD is meeting, right? This AD is meeting. Right, so it's produced and it is meeting over here at E and AC at point L. Now check what we have to prove here that EL, where is EL? You can see from here the length of EL is this, is 2 times BL, which is equal to 2 times of the length BL. That means 2 times of this BL. That's what we need to obtain a relation between them. Or alternately, we can also write from the to prove part that EL over BL should be equal to 2 over 1. So clearly, we are going to prove two triangles similar to obtain their sides proportional and finally ratio as 2 is to 1. Now one triangle is this and the other triangle is this. Now how can we prove these two triangles similar? What I can see, number one, I can say that this angle will be equal to, say 1 is equal to 2. These are corner angles and reason opposite sides of quadrilateral parallelograms are parallel. And similarly, I can write angle, say this is angle 2 should be equal to angle 3. And the reason here will be same, that these are corner angles also can be called as alternate interior angles. So let's begin with proving the triangles similar. First, I'll consider these two triangles and we'll write down the angle here. Angle 1 is equal to angle 2 and I may no, not angle 1 is equal to 2, right? This is 4, has to be 4, and angle 4 is equal to angle 3. This way we can write the triangles similar, and the similarity condition has to be angle. So once these two triangles are similar, check here, we can write their sides as proportional. So I'll be writing EL over BL, right? EL over BL, this is EL over BL, because this is what we have to obtain, should be equal to what? I can write AE over BC, that is AE over BC. So you can figure out that we have obtained this, and then we have to modify this RHS so as to get 2 over 1. Right, to do so, we are going to use the concept of congruency over here. So let's say I once again consider two triangles, and the triangles considered is going to be what? Let's check here. So let me erase these things. We have used it. This time I'm going to consider this triangle. One triangle as this and the other triangle as this. We can prove these two triangles congruent and use the corresponding sides being equal. So from here, one thing is clear, that we have this side is equal to this side, and we can write these two as vertically opposite angles. So I write angle 5 and 6 over here. And similarly, this angle 7 will be equal to this angle, the whole angle, right? This angle as 8. So we can write the triangle congruent. Let's begin with proving the triangle congruent over here. So I start with considering the two triangles here. And after considering the triangle, what we'll do here is to prove them congruent. So the first thing that we can write over here is number 1, that is angle 5 is equal to angle 6. That's by vertically opposite angle. We have the length DM is equal to CM. And then one more thing, that is angle 7 is equal to angle 8. So this is clearly congruent, and the congruence condition will be what here? That is by, we proved it by angle side angle. Yeah, that's by ASA. So once the triangle become congruent, what you can do is to write their corresponding sides equal. So here the sides which are going to be equal are these two. That means I can write the length DE is equal to BC. Further, you can see that AD and BC are opposite sides. So BC is equal to AD as well. That's by opposite sides of parallelogram. So if I mark this equation, say if I mark this as 1 and this as 2, let's say what we are going to get after using 1 and 2. So what you can see, AE, look into the side AE. This is AE is actually can be split as AD plus DE. So that is what I'm going to do here. I'm writing AE. Check again. I'm going to split this AE as AD plus DE, and that whole divided by BC. Let BC be BC only. Further, this is EL over BL is equal to, check here, AD as well as DE are equal to BC from the second equation. So I can write this as BC only, right? BC plus BC, that divided by BC. So we get what? 2 times BC. So on the right hand side, we can write EL over, on the left hand side, EL over BL, and this is 2 times BC over BC. BC get cancelled. And if I do cross multiplication, from here, we can say that EL is 2 times of BL. That's right. Yeah, this is what we need to prove. That's how we will do this question.